And thank you for volunteering to join the citizen science team. I'm going to run through the testing which we'll be asking you to do. But before doing that, I want to emphasize that we take safety very seriously. So when you are allocated a testing site, you will receive a risk assessment, and it's very important for you to read that before you go to your site. Most of the sites are very safe, so it's not something that should trouble you too much, but you need to be particularly careful if your site happens to be on a busy road where you're likely to be troubled by traffic. But otherwise, the sites are generally safe, and it's just a question of being cautious and careful, and all will be well. So we do a number of tests. And most volunteers will be doing 5 tests, and these are for turbidity, nitrates, electrical conductivity, temperature, and phosphates. And it's good to record your results in a little book, and this happens to be one that I use, which the headings are the 3 sites that I test. The tests carried out are listed here in this column, and the results are entered manually in these columns. So that this is the testing that I've been doing today. I've done 2 of my 3 sites so far, and the results for the 3rd one will be added here. It's important to record manually, but you will be loading your data onto an app called Epicollect 5, which I'll come on to later. The reason for recording it manually is that it's very tedious to record each reading as you take it. Once you've got them all in a book, you can run through the loading process very quickly and easily. And also, if anything goes wrong with the app or with your phone, then you've got a record of your results. So let's start with turbidity. Turbidity is basically a measure of whether or not water is clear or cloudy, to put it very simply. And on Epicollect, there is a simple observational measure of turbidity. It starts with clear and goes through slightly cloudy, more cloudy, and so on, until you come to something that's very turbid, in which case it talks about the color of the water, coffee colored, or and so on. But all these fields are on the Epicollect app, and you simply need to select the one that best matches the color of your sample. I should add that almost always the water is clear, and that's especially so at the moment because we've had no rain for quite a long time. So turbidity is as simple as that. It's simply an observational thing. The next one we're to cover is nitrates, and this test involves the use of nitrate strips, which come in a little tube like this. Each tube contains 25 strips. So those will keep you going on one site for about 6 months. Each strip has 2 tabs on it. It's important not to touch the tabs when you take them out of the tube. The one that's of interest to us is the top tab, which is measuring nitrates. This one is for nitrites, which are not of interest to us. I have a sample of water here, and one simply dips the strip in the water for a second or two, and then put it down on a flat surface and leave it for about 30 seconds or so, after which the tab on the end will change color depending on the nitrate concentration. So we'll leave that for a few seconds to do its thing, and we'll move on to Hanna phosphate testing, which is a rather more sophisticated test using this device, which is a Hanna checker. This is my own model, so it's a big grubby. It's been in use for about 3 years. And it works basically on the color of the sample after a reagent has been added. So the first step in this process is to take these 2 glass tubes from your box. These are called cuvettes, and they're made of optical glass, and they have on them a line which shows when they have a 10 milliliter sample. So the first task in this test is to fill 2 cuvettes with your sample, which can be done from a small jug like this, or some people find it easier to use a syringe, but the little jug is fine. I should have mentioned that to take your sample, you need a very simple arrangement of a jug with a piece of string on it, basically. This is the one that I use. They're very easy to knock up. You can get a jug from any supermarket for about 80 pence. Bit of suitable cord or string and some means of lowering it to the water. If you're going to use a plastic jug like that, it's important not to leave the sample in it for too long, but as soon as you've taken it out of the stream, to put a smaller quantity, ideally in a stainless steel jug like this, to avoid any contamination that might arise from the plastic. So this is actually the part of the sample that we'll be using for testing. So I've filled one of my cuvettes. I'm now going to do the second one for the Hanna test, similarly to the 10 ml line. Now, one of these is for calibration purposes, and that will simply be a sample from the stream with nothing added. The other, the second cuvette, will have reagent added. The reagents come in sachets, and they're in a strip like this. And the first job is to find the end and tear off a sachet. The reagent is in powder form, so it's important to shake it down to the corner of the little sachet, because the next thing we're going to do is to tear off these 2 edges, and if you don't shake it down, of course, you're going to lose some of the powder. So we've shaken that down, so now we tear off the edge along the dotted line. You can use scissors for this, but it's perfectly easy to do it simply by tearing it, as I'm doing now. Okay, so it's important to dispose carefully of your debris, and I usually just put it back in my bag and take it home and clear it out from time to time. So now we have to form this sachet into a funnel, which is done like so, which enables us to pour the reagent into one of the cuvettes. So this is the cuvette, and I'm now pouring the reagent in. Make sure it's all come out. Yes, it has. So I can throw that away. It's important here to note that we now need to dissolve this reagent, and when it's very cold, it takes quite a long time to dissolve it. So you can either warm it in your hands, or if it's really cold, you can take it home and let it get up to room temperature before you do the test. But if you are going to take any samples home for testing, it's important to record on Epicollect while you're at the site where you are, in other words, the location, because if you do the test at home and then enter the data at home, Epicollect will assume that that's where you've taken the sample, which is obviously not correct. Now you'll see something very interesting here. This is the second cuvette with the reagent. It's not fully dissolved yet, but it's already turning quite blue. You can probably see that. And there's an interesting point here, because this sample that I'm using for demonstration today is actually a sample of Welsh water, tap water. It's not taken from a stream. And the reason that I'm doing that is that it enables me to demonstrate what happens when you have a high concentration of phosphate in the water. This Welsh water sample has probably about 2 parts per million of phosphate in it, which is why it's turned quite bright blue. The likely readings that you'll get from the streams that you'll be sampling are much lower than that. And this raises an important point. You should never wash out your equipment in tap water. Otherwise, you'll be introducing into the cuvettes some water which has in it a very high concentration of phosphate. So going back to the tester, the checker, the first step is to put the blank sample, the calibration sample, which has nothing in it other than water, into the device, close it, press the button. We're now getting a display which says add C1, press. C1 is cuvette number 1. So now I press, and it's now calibrating, now thinking about calibration, and now it's saying add C2 and press. So we take out cuvette number 1, like so, and put in cuvette number 2. There's an important point here because it says add and press, but unlike with C1, we have to press and hold. There. Now, it has now started to count down from 3 minutes. And once that reaches 0, it will give us a reading. So we'll put that to one side, let that happen. And meanwhile, we'll look at the result of the nitrate strip test. This has been standing now for more than 30 seconds, but that doesn't matter very much, providing it's done reasonably soon after the test. But you'll see that that tip has changed in color, and that's simply compared with the nitrate calibration colors on the tube. It's important to ignore the bottom one, which is to do with nitrites. So we run along here till we get a match. It's certainly less than 5, and the closest match would be 2. This is quite unusual, but it's because we're using tap water. One would expect normally on a stream the nitrate reading of between 5 and 10, in which case this color would be closer to the colors on the tube here for 5 and 10. It's not possible to enter an intermediate value, so you have to decide which of these it's closest to, and in this case it's clearly 2. Okay, so that's all there is to it when it comes to nitrate testing. Our phosphate test is still counting down, so we'll leave that for a bit, and we'll move on to this device, which is called an EC3 meter, and this performs 2 functions for us. One is to measure electrical conductivity, which is essentially a measure of how much dissolved material there is in the water. The higher the content of dissolved salts, the higher is the electrical conductivity. The units are very strange. It's measured in microsiemens per centimetre. But there's no need to be concerned about that. It's the value that matters. And normally we'll be looking at something in the range 200 to 600 units. So the first step is to switch it on, and then to put it into the sample, which is down here. I'll use the big jug for this. It's now delivering a reading, whether you can see this on the, and you'll see that it's moving around a bit. It's necessary just to agitate the device slightly and leave it until the reading settles down. That's pretty stable now at 308. It's just gone to, there we are, 307, 309, 308. So that's, I would record that as a 308. And now we've got electrical conductivity. We press the temperature button and it's exhibiting 20.1, which is the temperature of the water. That's unusually high, of course, because this water has been standing in a bottle for a long time. And it would be rather unusual to to have a temperature in a stream of over 20 degrees. If it were that high, it would cause big problems for any fish that might be in there. So that's our EC3 meter, and we've covered off electrical conductivity and temperature using this device. And I'm now going to go back to the phosphate test, and you'll see it's come out at 1.93 parts per million. I've been testing on the Garum Brook this morning, which is very close to where we are now, and the reading on the Garum Brook was 0.44. So you'll see there's 4 times more phosphate, 4 times more phosphate in the Welsh water tap water than you're likely to find in any of the streams that you'll be testing, which is why it's very important to wash out your cuvettes in stream water rather than tap water. Very unlikely that you'll ever see a natural sample that shade of blue. It'll be much paler than that. It's important to emphasize the washing out. I've, in the interest of not making this presentation too long and boring, I haven't washed anything very thoroughly, but ideally before using your cuvette, any cuvette, you should wash it out 3 times using water from the stream that you're sampling. To do that, you simply fill it half full or so, shake it up, pour that away, and repeat a further 2 times so that your cuvette is scrupulously clean before you carry out the test. The other point to bear in mind is that you should take with you a piece of cloth, happens to be a piece of an old shirt of mine, and use that for making sure that before you insert a cuvette into the device, it's both very clean and perfectly dry. The tester is actually an electrical device, so it's important to keep water out of it. And I think that's it as far as the testing is concerned. So I'll now show you the way in which this data is entered onto the Epicollect database.